Good morning, dear students. Today, today we will do some questions. You are having some problem in some questions, so we'll solve those questions and we'll do some more questions further. Okay. So, all right. So this was the doubt. The question says minus under root of minus 4 whole cube. So we know what is whole cube. Minus of this into this into this. Same thing we have to we have to multiply 3 times. Now as we know that this minus minus, it will be plus. This minus of under root 4 is here, and we know under root of minus 4 and under root of minus 4 will give you minus of 4. Now these two minus will give you plus, so 4 root of minus 4, and we know in under root minus 4 it can be written as minus 1 into 4. 4, when it will come out from the root, it will be 2 and minus of under root of minus 1. So under root minus 1 will give you I, 4 2s are 8, and writing it in the proper form 0 plus 8i, like this. Okay. Okay, let us come to the 23rd question. If a plus ib c plus id is equal to a plus ib, then show that a square plus b square c square plus d square is equal to a square plus b square. So first of all, let us multiply these two brackets. We got this step is equal to a plus ib. Okay. See, now what will be my way of teaching? I won't explain you that how these two brackets have been solved, because as in you are a matured math student, so you can understand that how this a is multiplied with these two and ib is multiplied with these two to get this 4 terms. And then after that, this I square is minus 1, so AC and BD, it become the real part, so AC minus BD plus taking I common, AD plus BC is equal to here as it is. So on comparing the real part, A is equal to AC minus BD and B is equal to AD plus BC. Squaring, let us square both the sides. So it will be a square, and using a minus b the whole square identity I have used here. Here also use the a plus b the whole square identity, so I have used here. Giving this and this as first and second equation. Now what you want a square plus b square as this thing. So you just add these two. So we need to add this RHS also. Now these two, they will be cancelled, and you are left with this 4 term. From this one and this one we have taken a square common, from these two we have taken b square common, and finally we got the answer. Okay, let us understand this question. And we have to find the modulus of the following: under root 7 minus 3i the whole cube. Now let us consider this is equal to z is equal to this. So as we know that a minus b the whole cube is a cube minus 3a square b plus 3ab square minus b cube. So we are using this identity in it. So this step has come after using the identity. Then root 7 the whole cube. What is root 7 the whole cube? Root 7 into root 7 into root 7. Root 7 will give you 7 and 1 root 7. Minus, this is 7 3s are 21. 21 into 3 63i. Here 3 square is 9. 9 into 3 27. Root 7 I square. Minus 3i whole cube is 27i cube. Then in place of this I square, minus 1, so minus of 27 root 7 plus 27 see, I square, I cube can be written as I square into I square is minus 1 into I, so you just remember I cube is equal to minus of I, so that is why it become plus and 1i. Okay, then as we know, this is the real part, so 7 root 7, and this is also the real part. Here I have written minus of 63i plus of 27 will give you minus of 36i. Okay, this is 7 times of root 7, and this is 27 times of root 7. So 7 times of root 7 minus 27 times of root 7 you will get minus of 20 times of root 7 minus 36i. Now we need to find the modulus of it. So modulus of z will be equal to minus of 20 root 7 the whole square plus minus of 36 square. The square of this is here, the square of this is here, and on adding we are getting 4096, and taking out from the root we'll get 64 as a answer. Okay, to do this question we need to just see that we have to solve for x such that modulus of 1 plus I to the power x is equal to 2. So we need to find the value of x So as you see that the x is in power, so we need to actually find that what power of x or what power should be here, so that on solving 1 plus I we should get 2 as an answer. So first of all, modulus of 1 plus I. What is the modulus of 1 plus I? Says modulus of 1 square plus 1 square, because the coefficient of real part is 1 and coefficient of imaginary part is also 1. So 1 plus 1, 2. So you just do a hit and trial method. If I put x equal to 1, so for x equal to 1, root 2 to the power 1 is equal to 2. Are they equal? No. So x is not equal to 0. For x is equal to 2, root 2 the whole square is equal to 2. So 2 is equal to 2. You are correct. So hence from here you say that the value of x is, hence the value of x is equal to 2. Okay. Alright, the next question is 1 plus I to the power 4 into 1 plus 1 upon I to the power whole 4. So you know the main challenge of this question is to remove I from the denominator. So first of all we are taking LCM, so I plus 1 upon I. Now to remove this I from the denominator we need to rationalize first. So let us rationalize inside the bracket itself, so I upon I. Alright, now what to do? Okay, so rationalized with I upon I, so it will be multiply I with all these things, so you'll get I square plus I, and this will be I square. This as it is. I square is what? Minus 1. So I'm writing first I, then minus 1, and I square is minus 1. Minus 1 to the power 4 will be unity only, 1 only, so that is removed. And this I am writing it as I plus 1, I minus 1, and both the powers 4. Now if the power is same, the base can be multiplied like this by the laws of indices. A plus b, a minus b, a square minus b square. Okay, I square minus 1 square. I square is minus 1, minus of 2 to the power 4, that is 16. So you can express in the complex number as 16 plus 0i. Okay. So here is one of the question in which we need to express a complex number in a plus ib form. So here you have 2 brackets in numerator, 2 brackets in denominator. On solving these two, we are getting this step. Now after this step, what will happen? I square minus of 1, so plus 6. 9i minus 4i will give you 5i. 6 plus 6 will give you 12 plus 5i. In the denominator, this will be plus of 2, 2 plus 2. Here it will be 4, and this will be 3i. Okay, now we need to rationalize because we need to express in a plus ib form. So rationalizing, we are getting this step. Then after that, here and here to here. So you have to understand it. Pause the video and understand the things, or just write it in your copy and make the things understand. Okay. Okay, let us come to the next question. If z1 is equal to 2 minus I and z2 is equal to minus 2 plus I, then find the imaginary value of z1 z2 upon z1 bar and real value of 1 upon z1 bar. So first of all, what we need z1 bar. So what will be z1 bar? Conjugate of 2 minus I, that is 2 plus I. So let me ask you one question over here. Just what will be z2 bar if it is minus of 2 plus I? So just try to understand, even if the minus comes here, this does not matter. The only matter is in between these two numbers, what is the sign, and that sign you need to change. So it will be minus 2 minus I. And one more thing, say for example, if you have question like this, so again this minus sign does not matters, it will be plus of this one. Okay, you can verify this result by this. Z2 double bar will give you Z2, as I taught you in the basics, that Z double conjugate will give you the same. So if Z2 is this one, so what will be conjugate of this one here? Now again you conjugate, so minus 2 plus I, so hence verified. So like this you can verify the logics, you can verify the laws, theorems like this in the question. Okay, all right. Now let us get back to the question. We need imaginary value of z1 z2 upon z1 conjugate. So z1 z2 z1 conjugate. Multiplying these two brackets, we are getting this and this one as it is. So minus 4, this will be minus plus 1, and this will be 4i upon 2 plus i. So minus 3 plus 4i upon 2 plus i. Now we need to rationalize this. So rationalize this. Multiplying these two brackets, we are getting this one, and this is a plus b, a minus b, but of course, so here, and after solving, we are getting this as an answer, and we need only the imaginary value of it. So imaginary value will be 11 upon 5. Now you try to solve this question right away, that what will be the answer of it. Okay, let us do this question. If a plus ib upon c plus id is equal to p plus iq, then prove that a minus ib upon c minus id is equal to p minus iq. And second, prove p square plus q square is equal to a square plus b square upon c square plus d square. Now let us give this as first equation, taking conjugate of first equation. So the numerator, then denominator, and here also both the sides. So it will be a minus ib upon c minus id is equal to p minus iq. This is the first proof. Now multiply first and second. We get first equation and second equation, LHS with LHS and RHS with RHS. So a plus b, a minus b, a square minus b square, a square minus b square, here also a square minus b square. I square is minus 1. So we got the proof. Okay, coming to this question. If z is equal to x plus iy and modulus of z minus 2 upon z minus 3 is equal to 2, then we have to prove this equation. So just substituting the value of z here as x plus iy minus 2 upon x plus iy minus 3 equal to 2. So taking the real part close, x minus 2 plus iy upon x minus 3 plus iy equal to 2. Now as in this is a modulus, so on removing the modulus, this will be under root of x minus 2 the whole square plus y square, and I'm taking this the denominator that side, so 2 times of under root x minus 3 the whole square plus y square. Now squaring both the side, so this root will be removed. I have removed the root and used x minus 2 the whole square identity here and y squared here. This 2 square will be 4 and the root will be removed, and I have used the identity here, the x minus 3 the whole square plus y square. Multiply 4 inside the bracket, will get this. Now you take all these things here, so finally you will get this as the equation. Solve it and just see are you getting or not. So that's it for today, my dear students. I hope you will do the question till 42nd, I think. 42nd. Okay, so do the practice, see the examples also. Okay, I hope you will do it. In the next video we'll just see 1 or 2 questions, the last 43, 44, 45, and we'll start the next topic. Till that, thank you so much. Have a nice day. Bye bye.